If humans did not evolve from ape-like creatures, then where did we come from? The Genesis account of creation states that God made Adam and Eve, not as mythical beings, but as the literal historical ancestors of all living people. They were the first two human beings created, with all humans descending from this first couple. From a purely genetic standpoint, is it scientifically feasible that all humans descended from a single mother and a single father? Many insist this is absurd, and yet the genetic evidence for a literal Adam and Eve is inside each one of us. It's found in our DNA.
In 1987, a milestone paper was published in the journal Nature by leading evolutionary geneticists who announced the results of a mitochondrial DNA analysis. Geneticists from the University of California found that all humans are descended from one woman thought to have lived in Africa 100,000 to 200,000 years ago. Their results sent shockwaves throughout the scientific community and called for a major rewrite of the evolutionary view of human origins to accommodate the new data. The revision gave rise to the now widely accepted out-of-Africa theory. Proponents of the theory couldn't help but notice its uncanny resemblance to the biblical Eve. In acknowledgement of this, they gave the genetic mother of us all the name mitochondrial Eve. According to the evolutionary perspective, mitochondrial Eve was an unnamed woman who evolved out of Africa from a Homo erectus population of ape men. Not long after the first mitochondrial DNA studies revealed a single mother of us all, evolutionary geneticists found similar results when analyzing sequences on the male Y chromosome. In 1997, a team of researchers from Stanford University reported to the American Society of Human Genetics that all men inherited their Y chromosome from a single male ancestor. The sequencing of thousands of Y chromosomes from diverse people groups living around the world has revealed an overall lack of Y chromosome diversity. All men share the same Y chromosome, plus a small number of mutations consistent with a single male ancestor of the human race. Once again, evolutionary geneticists couldn't help but give the father of us all a biblical name, Y chromosome Adam. Just as they did with mitochondrial Eve, evolutionists interpret Y chromosome Adam to be an evolved ape man from Africa that lived sometime around 100,000 to 200,000 years ago.
The evolutionary community acknowledges that there is a literal Y chromosome Adam and there is a literal mitochondrial Eve. They say it's clear that all of the Y chromosomes on this planet trace back to a single individual who didn't live so long ago. The Y chromosomes only passed on through the male, right? Father to son. Well, the mitochondrial chromosome is only transmitted through the female. And that chromosome also, all the geneticists agree, all people on the planet get their mitochondria from a woman who lived not so long ago, and it's uncontested. And it turns out initially the evolutionists said, yeah, but it looks from our estimates of how long ago those individuals lived, that they didn't live in the same time span. Now actually if they've reworked their numbers, they're always reassessing their time scales. They're Adam and Eve, the mitochondrial Eve and the Y chromosome Adam, they are in the same time span.
There are two fundamental differences between the Adam and Eve of the Bible and the evolutionary interpretation of mitochondrial Eve and Y chromosome Adam. The first difference has to do with time, and the second has to do with population size. The Genesis account indicates Adam and Eve lived recently, just thousands of years ago, and that they were the only two people alive at the time of their creation. The evolutionary model claims they lived around 100,000 to 200,000 years ago and belonged to a hominin population of 10,000 individuals. But as you will see, it's not the genetic data that conflicts with the biblical account of Adam and Eve. The conflict comes from inferences about time and population size.
Evolutionary geneticists estimate that genetic Adam and Eve lived around 100,000 to 200,000 years ago using a method known as the molecular clock. The technique relies on the assumption that mutations accumulate in certain regions of the genome at a constant rate over deep time. Evolutionary scientists have to further assume that humans evolved from a chimp-like ancestor roughly 6 million years ago in order to calibrate the molecular clock. Both claims are problematic and have been called into question by the genetics community. Distinguished evolutionary geneticist David Reich of Harvard confesses in the publication Nature, "The fact that the clock is so uncertain is very problematic for us. It means that the dates we get out of genetics are really quite embarrassingly bad and uncertain." Scientists are now using a more straightforward approach to determine mutation rates that do not require ape-to-man evolutionary assumptions. It involves directly measuring mutation rates in the present, comparing parents and offspring, known as the pedigree method. When comparing DNA sequences between parents and children, the measured mutation rates are typically 10 to 20 times higher than those inferred based on assumptions of ape-to-man evolution. When the molecular clock is calibrated using the empirically measured mutation rates, both mitochondrial Eve and Y chromosome Adam lived just thousands of years ago. In discussing the age of mitochondrial Eve, evolutionary scientists in Trends in Genetics acknowledge this discrepancy. mtDNA datasets often exhibit anomalous patterns. One of these anomalies is the discrepancy between mtDNA mutation rates observed in evolutionary timescales, for example, in dating the divergence between two species and those measured within family pedigrees. If the high mutation rates seen in some human pedigrees were used to calculate the age of our most recent female common ancestor, she would have lived just 6,000 years ago, a date more consistent with biblical Eve than mitochondrial Eve.
There's a long-standing debate and argument in genetics, and that deals with the difference between what's called the phylogenetic mutation rate and the genealogical mutation rate. If you look at a family, you can count the differences between the people and you say, oh, they've had some mutations. And you can actually calculate a mutation rate over time in today's time, in known time. Right now, we know what the mutation rate is. But the evolutionary community doesn't like to use that rate because it's too fast. They use what's called the phylogenetic mutation rate. That is, they look at the difference between humans and chimpanzees, not the real rate, but the differences, and they say, oh, we've been separated for so many millions of years. Now, when I was an undergraduate, that difference was 3 million years. Now it's 6 million years, 6.5 million years. Some people are arguing for 13 million years because mathematically they're having a hard time dealing with this. Take the differences between humans and chimpanzees in some gene, like mitochondria, Y chromosome, or something like that. Divide it by the time that separates us, 6 million years. You get a very slow mutation rate. But if you look at the people alive today, count up the number of differences between them, and divide by the time since their ancestor, maybe their great-great-grandfather or something like that, and you're going to get a mutation rate much faster. When we use that rate, Adam and Eve fall into the biblical time frame. So when we use today's science, measurable science, laboratory stuff we know is true, Adam and Eve are biblical.